Now this is the all billet SML. We're going to be putting in the sleeves with liquid nitrogen. We have just done a final clean up on the deck surface to verify and get our protrusion correct on the sleeve. So we're at 5 thousandths of protrusion on here. And now, let's see. There we go. You can see the shiny goodness. Shiny. Got to touch the shiny. It's nice. So anyways, we're going to start putting the sleeves in this thing. Like right now, we're going to leave it in the machine because then we need to put the receiver grooves in the sleeves. And then we're going to be taking it out of the old Rottler F69 and then putting her in the king of all hones to hone the cylinders. So we'll just go through that real quick with you. And I'm telling you, every time I don't even use this machine very much myself. I make Brock do it. That's why I'm going, I don't want to press the button because I'm not 100% sure. But the hone, I'm 100% comfortable on. And every time, I'm telling you, every time you use these machines, it just makes me remember how much harder life was before I had them. So anyways, let's put some sleeves in here. We're going to put the liquid nitrogen in the little styrofoam cooler and then dip some sleeves, pop these things in. Boiling. Check it out. It's really pretty fascinating thing. So I'll kind of wait till it stops boiling, which would basically mean it has reached its temperature. Aha. One. Well, I already got the other side done. Two. Now I'll put these other ones back in here. And we also just got done checking the balance on the crankshaft, and they already hit the bob weight from Cali's. So awesome. Don't even have to mess around with that thing. So that's all done. Would have shown you that, but it's all done. And we'll wait for this to finish up here. Basically, when they stop boiling, like that one, all of a sudden it like just stops. Now this one's still boiling. And it'll probably just like stop all of a sudden. Yeah, right there. It just stops. Pretty interesting. It's worrisome because I keep on getting the gloves caught underneath the lip, and once it sets in there, then I'm screwed. Ta-da! As difficult as that. Then it'll just kind of, now these are 5 thousandths protruding above deck surface. Alright, just making sure they're all the way down on the bottom. You can hear it definitely a tone change when you do that. And now you can see through here too. This thing has really nice water jacketing, just like my SMX does. Comes in the cylinder. This is the head stud area. head stud threads start right there at my finger and go all the way down, so it doesn't pull on the deck surface. You see how thick the minimum thickness on deck surface is here, and then it still has 1 inch or more cylinder wall thickness. This would be the thinnest part of the cylinder wall right here, and that is a solid 1 inch right through there. So that all looks good. We're gonna put the receiver grooves in this block, get this thing out of the machine, put it over in the home. All right, now we have all the sleeves in here, and now Brock is going to come in here and put the receiver grooves in, but we're gonna verify our sleeve protrusion. Is where we at here. Yep, 5, 5, 5, 5. I already checked this side, so that's how we're checking our sleeve protrusion. This is zeroed off a deck surface, so these sleeves stick up 5 thousandths. Why I do that is it forces the sleeve down. It's a copper head gasket, and it actually kind of makes a whole little tight pinch sandwich area. Cool sandwich, you know. It's like that, you know. So not only does it have the hoop and receiver groove, which is like this, it actually all the way around it, it's also impregnating into the copper gasket and really getting a much tighter seal. And since there is no water going through the deck surface here, it doesn't even need sealant or anything technically. I usually will put something up here because sometimes it actually can seep a little bit of oil, but since there is no water here, it will not leak. And if ever did blow a head gasket, which is really hard to do, giving the head bolt pattern that's here, the 6 bolts per cylinder, 1, 2, 3, 4, 5, 6. Yes, it shares 2 half-inch head studs in a symmetrical pattern versus just 4 on a normal LS. This has superior clamping and superior deck thickness, superior material, cylinder head and block. So really good. So we're gonna go, Brock's gonna do a couple quick ghost cuts, make sure everything is in the correct location, and then we'll go through and put that receiver groove in there. But you can see what it looks like basically right here, and we'll show you it's cutting the first one. How much are we gonna cut? Just a couple? Yeah. So all this is gonna do right now is just gonna cut a couple thousandths because we want to verify it's in the right spot, everything looks correct on all the holes. Then we come in and do the final 2-depth cut. Right now it's cutting air. It cuts air very accurately. It's amazing. Every time you remeasure it, it's like perfect air. If only everything else was perfect. There you go. Now Brock's already just touched off on this one, so that's probably all it's going to do. Oh, at least I heard the touch. Is it still going?
That's going back up now.
Oh, there you go.
It stops at the bottom and kind of like do.
Oh, yeah. Yeah. Sparks out. It's a very slow feed, so I mean, here's a distance to go, 18 thousandths, 17 thousandths. So it just takes us a little bit here to go through, but it's a whole lot better than crashing the machine. Here you go. Now it's getting close. 4, 3, 2, 1. Sparks out. It's not cutting any longer. Don't freak out. Not gonna throw my finger in there. Such a jerk. Looks right. All right, cool. And that's it. So we'll get this thing finished cut. Next time you see it, it'll be in the home. Okay, so you saw we did the receiver grooves, got the sleeves in, had deck block to get the sleeves to the right height and everything to be stacked up correctly for protrusion of the sleeve. And so now we have to come over here and we're doing some stroker clearancing. So I already have this all clearanced. I already have this block we went right from there and went over to the king of all hones, got it all honed. I had to hone lifter bores the size. I didn't bother showing you that because you can see those kind of videos on my other videos all over the place. So I wanted to focus real specifically on what the features of the SML are. Now, but I thought, you know what, one thing that we could probably cover is stroker clearancing. Now, this is a block, this is the SML that I already have honed, everything's all done, and we've already clearanced this. Now, you might be thinking to yourself, gosh, can't you just program it and have the 5-axis CNC machine do it? Yes, ultimately you probably can, but ultimately we can, but right now we're still, I need to figure out where things all at and how I want it to work and how I want to really see how it really fits, really works, not just on a drawing on CAD. So I'm going through here. You can see really nicely how this lays out if you want to jump on this stool there. So these are the flats right here. This is for the bolt, flat bolt, flat bolt, flat bolt, flat bolt. Once you have one done, actually then I just do the math. I'll show you that. So this is the main cap, 1, 2, 3, 4, 5. So I do all this stuff by hand first and figure out all the math of where everything's all at, where I need to place it, how far I need to cut, and then ultimately we can transfer this into CAD to cut them. But this is my point of origin right here. These are the shape that I'm going to, that little shape right there, little shape right there, little shape right there, and then on the opposite side. So this is all the math I just did this morning in order to get this clearanced. So I didn't have to sit there and manually do each one and check it. This way I can do one, I set it all up, measure it, and then I can duplicate to the next holes with different offset for the other side. Then I come in and just check it and verify that everything looks right. Looks perfect, looks real nice, no problem there. The one thing that I do want to show you, it's going to be a little difficult to see, let me get a light here, is how far, now this is the bottom of stroke. So you can see right there, that is how far, that is the maximum that the piston comes out of the bottom of the bore. If you know anything about LSs, you know that the LSs struggle with having the piston come too far out of the bottom of the bore. They rock real hard, so they have to do different design work on the piston, and you're always trying to do stuff. But that, because I have extended my sleeves, extended material behind the sleeve, is all of the piston comes out of the bottom of the bore. And that's on both sides. So that's going to add and make a very straight, very stable, very, well, it's just very stable piston. Keeps it from rocking and doing all sorts of weird, stupid stuff. So that's a much better feature. The bottom of the bores and the sleeves are machined and blended in really nice. So it's all very nice. I'll show you that here in just a little bit. So we're going to take this crankshaft out. I'm going to run this through a cleaner because this would be my final mock-up stroker clearance. So it should be, after I clean it, it should be ready for final clean and then ready to start assembly. So I'll go over a whole bunch more stuff of all the features, from the water jackets to oiling to the main caps to how this all fits, works, and goes together. So went to clean this up and do a little bit more mock-up before I showed you more stuff on film, and lo and behold, the thrust bearing went in the cap side fine but would not go into the block side. So I checked all the blocks, which are sitting over there. So out of 6 blocks, 3 blocks are wrong. They forgot or didn't hit one procedure on here. So I'll show you right here. You can see that this tool right here, which I'm going to show you running, which is actually really fantastically cool, because this is, I don't even know how you would do this all together without having a machine like this, but I'll show you how this is working, because this is really cool. But you can see here it cuts down here because this right here is thicker than this. They didn't finish this final size, so we had to put the block back up in this machine one more time, and now we are cutting this flange to the proper dimension right here. And I'll show you how this works. It's pretty cool. Now we have this other cap off, and this thing running down like that just freaks me out. But now what this 90-degree head is doing is it's not cutting like it's one pass, it's a single point tool that is actually, you gotta watch this here. So that tool is spinning around like this. So it's spinning around like that, going like this. So it's moving in all these directions. See, that looks pretty good. That's about legit. Yeah. That's exactly what it's doing. So it is coming in here. So you can see it's still not touching up on the cap portion because that's exactly where it's at right now. But it's still cutting down on the bottom. So we're gonna sneak up on that and then make it correct width so the bearing fits in there properly. Then we're gonna final clean this thing and then put it over there and start assembling until I find the next little issue that we always take care of. So this is an important thing too. This is 100% normal. This is how custom engines go. This is how big money, big custom engines, building things, developing things, making things happen that aren't happening yet. This is not a 350 Chevy. This is not a LS3. Okay, they've paid millions of dollars to hundreds of engineers and hundreds of people machining and developing and testing and screwing stuff up to get an LS to where it's at before they even released it. I'm doing it and my guys. So that is what's going on right now. So we're cranking right along. Now let's start showing you some of the features on the SML block. All right, let's start out from the top. There's a water jacket on the outside. Let's go over here. Now, just some of these features that are here. 904 lifters. Most importantly through here is the head bolt pattern. Now, I know I've talked about this on lots of other videos and whatnot. Let me show you how this fits and goes in here. So these, whoop, there we go. 1, 2, 3, 4, 5, 6 half-inch head studs. Not just a half-inch, 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 some stupid 3/8, some stupid 3/8 or whatever size they are. And we have moved these out to become more symmetrical. So in a standard pattern LS, these are actually closer in here like that. So I moved them out, trying to get more uniformity in between the bolt hole spacing. And this bolt hole right here, now that goes through the top of the intake port to access that. So there's a plug in top of the intake port. I'll show you that when we get to the cylinder heads. So cylinder head clamping. Now to take a look here, you can also see this is the outside of the cylinder wall. There is no water that goes in between the cylinders. There's only water that comes in from either side through here or through here, through these channels. Then goes through all the way down here, crosses over in the back, comes around the back side through here, right to there. You can see my little finger there. Where is it? There you go. Okay. Along the entire outside. Now this is head stud sleeve through here. Head stud sleeve comes in around the jacket. This is a head stud. Also, sleeve is the wrong word. This is just all solid billet. There is nowhere in here that there's less than 3/4 of an inch of material. Most of it actually is all 1 inch and more of cylinder wall thickness all the way around. Super stout. Maximum cylinder head clampage. Since this is all solid, so this is solid all the way down. 3/4 of an inch all the way down. 3/4 of an inch all the way down. So the deck surface, if per se if you want to say that, is, I don't know, I guess you could say it's about 5 inches thick, because all this whole area where the gasket seals is solid all the way down. All right, next thing. So extreme duty and cooling for street applications or endurance, long duration. There's other billet blocks out there for LS type stuff, but they're not water jacketed. Only a couple, or they're made for something a little bit different, or they still have a stock head bolt pattern. Totally different head bolt pattern, only fits our cylinder head. All the SMLs come with a 55mm roller cam bearing. Priority oiling. Lift your galleys back here. Still takes a stock style, well, for LSX front belt drive, or we're working on a gear drive for it also, but currently it's just a belt drive in front, and even uses a stock cover in the back. All right, so all that's still all the same. Everything's plated for the water. Now we go to the main cap section. Now this is still a raised skirt block, so still fits all your normal LS componentry. If you had a daily pan or had something like that, this still all fits just like normal. But you can see here the main caps. Where are we at here? 5, 1. Okay. The main caps, billet aluminum. Now, some people say, you know, have comments about it should be a steel cap. No, it shouldn't. Top fuel cars that make 12,000 plus horsepower still use a aluminum cap. So, pretty sure 3,500 horsepower plus doesn't have to have a steel cap. Plus, when we do this, growth is still all the same. So you put a steel cap on aluminum block, they're growing at different rates, they're moving, they're walking, they're doing a lot of little funny stuff. So I prefer to use aluminum cap. And I do that in my SMX stuff too. If you look here, this is all machined in radiuses. So no sharp corners up in here, no sharp corners up in there. This is all radius. Everything through this entire block has a very generous, nice radius work, but definitely right in here, right up through there, right in that radius there, as you can see. Also, Cleveland, Maine. Let's discuss, oh, I'm sorry. The caps are all dowel pin, like that, all right? 4-bolt splayed. So instead of this bolt coming over here where you're just depending on that bolt being able to be sheared off, the bolt is actually going into the main, or I'm sorry, going into the bulkhead right through there and tying the entire block together. Not just having it cross bolted, but angle splayed going into the bulkhead. So makes a stronger, better, more captured, let's say, piece. Now, back to the main saddle size. Cleveland, Maine. If you don't know what the Cleveland, Maine is for LS type engines, the Cleveland, Maine is all about a larger diameter main shaft, because what that does is it makes the crankshaft stronger. Excuse the mess here. Makes the crankshaft stronger, and by doing so, bearing speed is not a problem, don't really care, but increases this overlap. When this journal comes up here and is, so imagine this is solid. All this area is solid. If this stroke was like a half-inch taller stroke, you would literally have only material. If this was, hard to say, if this was not overlapped right here, that's called the overlap, or what I call it, that is adding strength to the crankshaft. If this rod journal is smaller and up here, or this main journal is smaller diameter, you lose strength right here. So imagine if this connecting rod was way up here, okay, way up here, and the bottom of this connecting rod journal was up here. You see the air gap there? It would literally only have the material that was right there, this very thin amount, that would support this connecting rod. So This adds strength to all crankshafts. That overlap. Important and boosted stuff that's making big horsepower. So what we're going to be doing here is I'm going to be putting cam bearings in. I've already checked my oil passages, cleaned everything, done a deburr, and now I'm going to start the assembly process of this. Already showed you clearancing, how that all works. Showed you bore and hone, deck, receiver groove. Show you a lot of that stuff earlier. So let's start getting this thing together. Before I actually do that, let's go over here. We'll talk about that. We talked about the crankshaft, Cleveland, Maine, standard pin connecting rod. That's a Callie's billet crankshaft. Connecting rod pistons. Let's go over that real quick before we start assembling, because that way I can get through the whole short block. Talk about the main caps. So here is the piston and connecting rod. Show you the piston. First, now this is called the forged side relief piston. It's not fully skirted all the way around. What this is doing is this makes a stronger piston. It's not always doable in other stuff. Let's get this pin out of here. Different designs, different bore sizes are get a little bit tougher to do. But the one thing that I do like about this is that it does bring all the strength and all the support right here. It does make a little better supported skirt out here. And we don't really need the skirt rails out here, you know, a full rounded piston. But it does make this cute little short pin. All right, now when that pin is shorter versus longer, so imagine a full round piston, the pin is usually quite a bit longer. This is a quite short pin. This thing is, can't remember, I think it's 2.5. Oh, 250. So this thing's 250. Most pins like in are going to be in like 2750 to 2950-ish long. But what they do is think about anything that's really long, a long rod. The longer the rod, the easier it is to bend. The shorter it is, the harder it is to bend. Short pin, short, very stout, thick wall. It looks like 250 wall pin. Yep, 250. So 250 wall H13 tool steel pins. Very stout, very strong piston. Now, this is also not set up for maximum compression ratio. This has got to be a drag and drive deal. It has to drive, pulling a trailer up and down hills, in the mountains, wherever they're racing, whatever's going on, wherever Jason's going to do stuff, wherever anybody's going to do stuff with these things. They got to be able to do it on regular fuel from the gas station. Any gas station. Not going to trailer around and haul E85 because you're in a part of the country that doesn't have E85. Got to put this on whatever the cheapest fuel is that you can run. Therefore, can't have a whole bunch of compression ratio in it just because it races on methanol. Connecting rod. These are R&R rods. Good high quality rod. This is a 6/100 long. I showed you how the piston, how well the sleeve captures the piston and how it doesn't come very far, only about 1/8 of an inch out of the bottom of the bore. So fully supported in the skirt area. Solid beam, big horsepower connecting rod. Very happy with all that. So let's start putting this thing together. Side note on the cam bearings. So I have the roller cam bearings in there now. They do not receive pressure fed oiling. Been running these, the vast majority of people run these. I've run these in drag and drive. I've run these in endurance applications all the time. One of the nice things is I don't even put a oil hole from the main down to here. And if I did, the rollarized cam bearing would actually block it off. There's no way to get oil into here because you don't need it. It'll rely 100% on splash and be perfectly okay. That's what it's designed to do, what it's made to do. But what we're gaining from this is if you knew how much oil was going by your cam bearings through that whole passage squirting out here, tons. So this is keeping all oil at the mains, at the rods, up to the valve train.